Now let's see the questions that are related to chapter 18 and what are the main concepts you have to remember related to chapter 18, Introduction to Organic Chemistry. First question, which compounds have similar chemical properties? So in organic chemistry, if you have these options given, you have to remember that only those organic compounds that have a same functional group will have the same chemical properties. Okay, so if you see over here, methane and butane, they both belong to A and E. The group is alkane. So they belongs to alkane group. It means they have the same functional group, which means single carbon-carbon single bond. So this is the right option. Only those compounds can have the similar chemical properties which belongs to same homologous series. And why they belong to same homologous series? Because they have the same functional group. So that's why option C is the only right option in these options. Okay. Let's see another question. Alkenes are homologous series of hydrocarbons. So these are the first group of the hydrocarbons, right? Hydrocarbon means they have only C and H in them. So these are some of the alkanes. Pentane is the next member of the series. Which row gives the molecular formula of the boiling point of pentane? So to remember the names, you have to remember that what does methane means. Methane means if it is METH, it means it has 1 carbon. Ethane, 2 carbon. Propane, 3 carbon. Butane means 4 carbon. And pentane means it should have 5 carbons, right? And for this one, to remember the molecular formula, you have to memorize the general formula of all the homologous series. For alkane, the general formula is CnH2n plus 2. So they are asking about pentane. It means carbon should have 5. We should have 5 carbon in this compound. So if carbon is 5, then it means you will have 12 hydrogen. So can you see 5 and 12? So option B or B or D can be right. Now let's see the boiling point. The boiling points of organic compounds always increase if the carbon number increase. So if you see here, this is 0. It means the boiling point of pentane will be higher than the butane. So which option shows you a higher boiling point? Of course, 36. Minus 51 means it is lower than 0. Okay, so D option is the only right option over here. Question 107. 4 statements about organic compounds P, Q, R, and S are listed. P is saturated hydrocarbon. Okay, to answer this question, hydrocarbon, we have only 2 types of the hydrocarbons. That is alkanes, the 2 groups, alkanes and alkenes. Okay, they are only hydrocarbons. And out of these, the saturated ones are alkanes. Alkanes are saturated, whereas alkenes are unsaturated. So it means P is an alkane. The formula for Q is CH3CH3. It is C2H6. It means it is also alkane. Okay. So this one is also alkane because the general formula for alkane is CnH2n plus 2. So these two are alkanes. Now let's see, a molecule of R contains only 1 oxygen atom. It means it belongs to alcohol group. Okay. Because alcohol has OH as a functional group. So only we have the hydrocarbons, it is only have 1 oxygen. So it is an alcohol, and S is carboxylic acid. It is another homologous series, right? So let's see which option is right. P and Q are the member of different homologous series. P and Q, they both are alkanes. So this option is wrong. P and S are the members of the same homologous series. P and S, wrong. This is alkane, this is carboxylic acid. Q and S are the member of same homologous series. Q is alkane and S is carboxylic acid. Again wrong. Q, R and S all the members of different homologous series. Yes, Q, R. Q is alkane, R is alcohol and S is carboxylic acid. So option D is the only right option in this question. Let's see question 108. An alkene is represented by the formula CH3CHCH2. Which name is given to this type of formula? So whenever they give you an open formula in which they show the structure of the compound, that first carbon has 3 hydrogens, second has 1, and there is also a double bond, and then the third carbon has 2 hydrogens. So it means it is actually the structure formula. General formula, for general formula you will see the word N or H2N like this type. If you see the word N, then that is called general formula. This is actually the structure formula, and display formula is like this. When you see the bonding also, okay, the clear bonding, if you can see, this is called the display formula. So now the right option is the D option. Question 109. The formula of the 5 compounds are listed here. Okay, which compounds are in the same homologous series? So to be in the same homologous series, they should have a same functional group, right? So let's see which one of them have a same functional group. If you see over here, this is OH, this one also have OH, and this one also have an OH group. This one you cannot see, cannot choose because it has two O, right? So it is COOH. This functional group is different. So 2, 3, and 5, they belong to the same functional group. So 2, 3, and 5, option B is the correct option. Let's see question 110. Which substance are structure isomers? So remember that what are structure isomers? They have same molecular formula but different functional, different structure formula. Same molecular formula, okay, but different structure formula. So how you can find it? You don't have to draw the structures, you just can look at the number of the carbons, because if the molecular formula is same, it means the number of carbons should be same. Butane always have 4 carbon, okay, you have to remember the names. It has 4 carbon, propene has 3 carbon, so it means they are not the structure isomers. Let's see ethyl ethanoate. So this is an ester. It means ethyl has 2 carbons and ethanoate also have 2 carbons, so total 4. And this is butanoic acid. So it also have 4 carbons, right? So these two can be the carboxylic acids and esters. They can be structure isomers of each other. Remember that carboxylic acid, which is butanoic, and esters can be structure isomers of each other if the number of carbons are same. So that's why option B is the right option. Why not this one? If you see here, methyl has 1 carbon, methanoate has also 1 carbon, right? Ethanol has 2. So you can say that, okay, they both also have 2 carbons. They can be structure isomers. No, because they both belong to different functional groups. One is alcohol and the other one is ester. Alcohol and ester can never be structure isomer. The 2 functional different homologous series that can be structure isomers are esters and carboxylic acid, okay? Ester, this is carboxylic acid and this one is ester. So now they can be the structure isomers of each other. So option B is the right option. Why not this one? Again, they both belong to same group, right? Alcohol. But the problem is that this has 3 carbon and this one has 4 carbon. So option B is the only right option over here. Which molecules are structure isomers? Again, when you are looking for the structure isomers, you don't have to look for everything. You just have to count the number of the carbons and hydrogen. If you count the number of the carbon and hydrogen in all of them, you will see only these two have the same number of carbon and hydrogen. So only the structure is different. So option B is the right option for this question. Let's see another question. The structure formula of compound Q is given over here. What is compound Q? So compound Q, first of all, you have to see the formula. What is the functional group? Which functional group is present? Then you can decide that, okay, this one belongs to which homologous series. So if you see in between the structure formula, you see COO. It means C double bond O. So then it is an ester because this is an ester bond, okay? So it means the esters names always esters we are always made by alcohol and carboxylic acid. Remember that. Okay, these two when react, they give you esters. And esters always, because alcohol has OH and carboxylic acid has COOH functional group. Whenever they react, alcohol will lose its hydrogen and only oxygen will be left, whereas carboxylic acid will lose its OH and CO will be left. That's why this COO is actually for carboxylic acid and this one is for alcohol, okay? So if you see here, we have C double bond O. It means this one is carboxylic acid and this one is your alcohol. Now you can predict their name. If you see how many carbons are present here, the name of alcohol should come first. How many carbons are here? 1, 2, 3. It means the name should be prop, okay? 3 carbons means the name should be prop. So it is made up of propanol. So whenever you are naming the esters, the alcohol name is propanol, right? So it will change to propyl. So your answer should be propyl. Can you see propyl here? Yes, these two options can be right. Now let's see for the carboxylic acid. The carboxylic acid is how many carbons here? 1, 2, 3, 4. So it means the name is actually BUT, butanoic acid. So whenever you are writing the name of the acid, in ester, the name will change to butanoate, okay? So propyl butanoate is the right answer for this question, option C, okay? So option C is correct. Again, let's see another option. Which pair of compounds are structure isomers of each other? Again, look at this. They must have a same molecular formula. How many carbons we have here? 3. 1, 2, 3, 4. So this option is wrong. How many carbon we have here? 3. How many carbon we have here? 3, right? Okay, this can be the option. How many carbon we have here? 1, 2, 3. 1, 2, 3. Okay, and 1 OH. Okay, this can also be the option. Then 1, 2, 3, 4. 1, 2, 3, and this is 4. Okay, so now this one is ester and this one is carboxylic acid, right? And I already have told you the two functional groups. There are two different homologous series, but if their number of carbons are same, then they can be structure isomers of each other. And if you see, we have 4 carbons in this one and also 4 carbon in this one. So this option is the best option. Now let's see why option B is not right. If you look at here, the double bond, because structure isomers means they have the same molecular formula but different structure. So double bond, if you see over here, it is between carbon 1 and 2, right? And if you look at here, it is also between 1 and 2. Why it is 1 and 2, not 2 and 3? 1, 2, 3, no. Because the numbering of the carbon will always start from where the functional group start, where the functional group is near, right? So again, this is 1, 2, 3. So again, this is the 1 propanol, right? And this one is also 1 propanol. The structure is not different. Only I have changed you can just say that they are the mirror images of each other. So this option is wrong. Again, if you see that OH, the functional group is with the first carbon. And here the functional group is also with the first carbon. So there is no difference between their structure. So option D is the only right option for this